Hello students, Namaste. Today let us continue the problems. The equation of motion for a mass at the end of a particular spring is given, that is y is equal to 0.3 cos 0.5 t meters. Find the displacement, velocity and acceleration of the mass at t is equal to 0. Displacement equation for oscillator is given, that is y is equal to zero point 0.3 cos 0.5 t meters in SI units. Then find, so what is y at t is equal to 0, what is y, what is v and acceleration. So comparing this given equation with the standard equation, we can find out the amplitude. So amplitude of this motion is zero point 0.3 meters and value of omega is 0.5. Now to get displacement at t is equal to 0, let me directly substitute value of t in this displacement equation. That gives me y at t is equal to 0. Y now I will represent that by y naught is 0.3 cosine 0.5 into 0 is 0, so cos 0, and cos 0 is 1, so it is 0.3 meters. Next is velocity, represent that by v naught at t is equal to 0, and velocity is given by omega into square root of a squared minus y squared, and what is value of omega? It is 0.5 into square root of amplitude squared is 0.3 squared minus what is the displacement at that time? Its displacement is 0.3, so it is 0.3 squared. That means the term inside the square root is 0 and v naught is 0, so its velocity is 0. The last part is to calculate acceleration. Acceleration is, we represent that by a naught, and acceleration is equal to omega squared into its displacement, that is y naught, and omega is 0.5 and its square into y naught is 0.3 meters, and 0.5 whole squared is 0.25 into 0.3, that gives me 0.075 with the unit of meters per second square. So the correct option is displacement 0.3 meters, velocity 0 and acceleration 0.075. A option reads correct. The equation of motion of a particle executing simple harmonic motion is a plus 16 pi squared x is equal to 0. In this equation, a is the linear acceleration in meters per second squared of the particle at a displacement x in meters. The time period in this simple harmonic motion is, so it is given that the equation of motion for an oscillatory motion is given, that is equal to a plus 16 pi squared into x is equal to 0. This is the equation of motion for that oscillatory motion. This equation can be rewritten as a is equal to minus 16 pi squared into x, and the standard equation that we know is a is equal to minus omega squared x. Therefore, by comparing the two, what I can conclude is omega squared is equal to 16 pi squared, or omega is 4 pi, and they're asking for time period, So time period can be written as 2 pi by t is equal to 4 pi, or kill this pi and 2 times, therefore t is equal to 1 by 2 seconds. The time period of the oscillator is half second. So option A is correct. Next question. Find the phase difference between two simple harmonic motions. Y1 equals 10 sine 10 pi t plus pi by 3, and Y2 is equal to 12 sine 8 pi t plus pi by 4 at t is equal to 0.5 seconds is. So we have two equations given. Y1 equals 10 sine of 10 pi t plus pi by 3, and the other equation is y2 equals 12 sine 8 pi t plus pi by 4. So the solution is that let us first calculate the phase difference. So this is the phase term of first displacement equation, and this is the phase term of second displacement equation. So I can write phase difference is equal to, call this as phi 1 and this is say phi 2, and take difference between these two. Phase difference delta phi is equal to phi 1 minus phi 2, or phi 2 minus phi 1. What is phi 1? It is 10 pi t plus pi by 3 minus 8 pi t plus pi by 4, that can be written as 10 pi t plus pi by 3 minus 8 pi t minus pi by 4. 10 pi t minus 8 pi t is 2 pi t, and pi by 3 minus pi by 4, so that gives me pi by 3 minus pi by 4, that is 2 pi t plus pi by 12. So this is the phase difference at any point of time between these two displacements. Now it is asked in the question that what is the phase difference at t is equal to 0.5 seconds. At time 0.5 seconds, what is the phase difference? So substitute value of t here. Phase difference delta phi equals 2 pi into 0.5 plus pi by 12, and 2 pi into 0.5 is pi plus pi by 12, and this can be written as 13 pi by 12. The option A is correct. The displacement of two particles executing simple harmonic motion are represented by the equations y1 is equal to 2 sine 10t plus theta, y2 equals 3 cos 10t. What is the phase difference between velocity of these two particles? So given two equations of motion for two particles, y1 equals 2 sine 10t plus theta, and y2 equals 3 cos 10t, 3 cos 10t. Now they are asking what is the phase difference between velocities of these two particles. So first we have to calculate the velocity. Let me do that by differentiating this term. So v1 is equal to 2 differential of sine is cos 10t plus theta and differential of this phase term is 10. And here velocity v2 is equal to differential of this displacement function, and that is equal to 3. Differential of cos is minus sine 10t into 10. Therefore you can write this as minus 30 sine 10t, and this velocity of the first body is 20 cos 10t plus theta. We have two velocities with the different functions, that is one is sine function, other one is cosine function. To calculate the phase difference, either it has to be cos or sine. So let me convert this velocity v2 into cosine function. This can be written as 30 into cos of 90 plus 10t. We know that cos 90 plus theta is minus sine theta. So now these two functions are having similar term, that is cosine term. Now we can find out the phase difference between these two. So I can write the phase difference delta phi is equal to phi 1 minus phi 2 or phi 2 minus phi 1, anything is fine. So what do I have here is 10t plus theta minus this phase term, this pi by 2 plus 10t. So we get 10t plus theta minus pi by 2 minus 10t, that is equal to this 10t cancels. Therefore I can write theta minus pi by 2 as the phase difference between the two velocities. Option C is correct.